Hello dear participants, I welcome you all again here in this certificate course. So we are starting today's lecture with this slide, and this slide been taken from week 1 of this certificate course. And in the week 1 we already have seen that the data is classified into two parts. First is the categorical data and the other is numerical data. So far inferential statistics is concerned, we can perform different hypothesis tests for the numerical data and categorical data. The hypothesis test which we perform for the numerical data, they are known as a parametric test, and the hypothesis test which we perform for the categorical variable or the categorical data, those tests are known as a non-parametric test. Non-parametric test. So far the parametric tests are concerned, in the previous few lectures we already have seen that how can we perform one sample t-test, independent samples t-test, dependent samples t-test, one way between groups ANOVA and two way between groups ANOVA. All those hypothesis tests are actually associated with the parametric test, and that parametric test actually performs the hypothesis testing on the numeric data. Now in the non-parametric test, we are going to discuss on the chi-square test, which is a very commonly used and the most popular non-parametric test which we can perform on the categorical data. So let me welcome you all here in this lecture number 32 with the title chi-square test of independence. So here are the two objectives of lecture number 32. The first objective is to make you familiar with the procedure of hypothesis testing for chi-square test using MS Excel and S.P.S.S, and the second objective of today's lecture is to make you familiar with the reading and interpretation of the results. So let me start this lecture with the prerequisites of chi-square test. So we need to have two categorical variables in our data to perform the chi-square test. And what actually we test here in the chi-square test of independence? Here in the chi-square test of independence, we actually test the hypothesis that the two categorical variables are independent of each other. So what does that mean? That we'll try to understand using one example. So let me take you to the further slide. So what is the procedure here in the chi-square test of independence? Here we actually compare two things. The first is observed cell frequencies and the other is expected cell frequencies. So what is the meaning of observed cell frequencies? Observed cell frequencies are the actual observation values or observed values. So they are the actual values, actual responses. And what is the expected cell frequencies? They are the number of cases that should fall in each cell if there is no relation or association between two categorical variables. What actually does this mean? That we'll try to understand with the example. Fine. So the basis of this chi-square test is the difference between observed and expected cell frequencies. Now to understand this in a better way, let me take you to one example. So here is the example of chi-square test of independence. Here is the condition given. Suppose researcher want to know whether the smoking habit or the tobacco consumption, you can take any one variable, smoking habit is independent of gender or not. It means suppose if we are having two questions that we are asking our respondent what is your gender, and say that we are going to get only two responses, say that one is male and the other is female, and the second question by our side is that whether do you smoke, and the responses that we are going to get are in yes no type. And here both the variables are categorical variable, both the variables are nominal variable. In such a case, how can we perform the chi-square test and how to construct the hypothesis statement? All this part we are going to discuss here in this lecture. Now suppose if we collect the data of 100 sample respondents on these two variables, gender and smoking, and that data, say that it looks like this. Here is our data. Here is the first, say that the nominal variable gender. Here is the coded data of gender. So the code 0 is assigned to male and the code 1 is assigned to female. So here is the coding for the gender, and for the smoking, here is the second nominal variable, and for the smoke, the code 1 is assigned to yes, that he or she smokes, and code 2 is assigned to no. Fine. So this is so far the smoking is concerned. So this is the way that we have collected data and we have given the codes. Now, how to construct statement here in the chi-square test of independence? Suppose if I go to the null hypothesis, the null hypothesis has been constructed in a such a way that the smoking habit, the the one or the first nominal variable, and the gender, the second nominal variable, they are independent, they have nothing to do with each other, or there is no significant relationship between the smoking habit and gender. So there are different ways that using different words you can construct your null hypothesis, but it should give the meaning that there is means both the variables are independent, they have nothing to do with each other, they are independent, there is no significant relationship. Now symbolically, if we try to present this thing here, then say that here the null hypothesis is mu smoke is equal to mu gender. But here is one problem. The problem is when we are performing non-parametric test, then usually we don't take into the consider mean. So mu is not useful here in the non-parametric test, or the mean, sample mean is also not useful here in the non-parametric test. Here the median works better than the mu or the mean. So this is all technical part, but for the simplicity we have just mentioned here mu. Here the mu, it doesn't mean the mean for us. For the sake of understanding, we have placed it symbolically. Now here say that the smoking habit or a smoking habit and gender, they both are independent. That we are saying here in the null hypothesis. So far the alternate hypothesis is concerned, this is exactly opposite to the null hypothesis, and the statement is like this: smoking habit and gender are dependent, or in other words, there is a significant relationship between smoking habit and gender. What does that mean? It means a particular gender has means kind of particular response. Say the male smokes more than the female. If such kind of thing is there, some variable is biased for some other variable, then if that biasness is there, then that is alternate hypothesis. In simple words, here in the null hypothesis, both the nominal variables are independent. Here they are not independent, they are dependent. So this is the way that we construct our hypothesis here in the chi-square test of independence. Now let me take you all to the procedure of hypothesis testing. And to go further, we need to type our data in Excel. Our data is already here in the Excel sheet. So what we'll do, we'll go for the S.P.S.S. Now suppose if I open my S.P.S.S file, it looks like this. So what should be the first step? The first step is to import the data. And to import data, simply I'll go to the file. Here I'll click on the file, then I'll go to open, and in the open I'll click on data. So this procedure already we have followed in many previous lectures. The same procedure we are following here to import the data. So here in the new dialog box or pop-up window, I'll go here to the type of file, and then I'll select Excel. Then and then only all my Excel files are visible to me. Then I'll choose the appropriate file, the file which actually I just want to import here in S.P.S.S. So I'll click on this, then I'll click on open. Then again I'll click on OK, and my data is here in S.P.S.S. Once my data is here in the S.P.S.S, then simply I'll go to variable view to redefine all my variables, to give quotes wherever necessary, to give labels, and to arrange all other things, basic things. And all this part we already have discussed in the first or second week somewhere. Fine. So once I redefine all the things, again I'll go back to the data view. And once I go back to data view, now my data is ready to perform statistical treatment. Now here we are going to perform the chi-square test of independence. And how to perform chi-square test? To perform chi-square test, simply we need to go to analyze option here. I'll have to click on analyze, then I'll have to go to descriptive statistics, and in descriptive statistics simply I'll go to cross tabs. So we already have seen that what is the meaning of cross tab and how it works somewhere in the week 3 or 4 somewhere. So simply I'll click on the cross tab. Now here I'll place the variables in the row and column. Now I'm going to select this gender code because we need to have coded data here to perform the chi-square test. So gender coded, I'll place this thing here in the row. You can place it in column, no problem. If you are having the two nominal variables, you can put any one nominal variable in any one of this, either row or column. No problem with that. Then I am going to place the second nominal variable, that is smoking, that is coded data, here in the column. Then what I'll do, if I simply press OK, I am going to get the cross table. But cross table already we have seen somewhere in the previous lecture. In today's lecture, we are going to perform chi-square test, and to perform chi-square test, we need to click here on the statistic. So here, if I click on the statistics, a new pop-up window comes, and here I'll find the chi-square. Fine. So simply I'll have to select this chi-square, and simply I'll have to click on continue. As I click on continue, again we'll come back to our previous pop-up window, and here in this window again I'll have to click on the cells. So if I click on cells, I'll have to select observed and expected values, because if you remember in the initial part of this lecture I've explained you that in the chi-square test there are two things, observed values and expected values, and the difference between these two are very helpful to take the decision. So we'll click here on the observed and expected, these two things, and then I'll press on continue. As I press on continue, I'll come back here on the my the main dialog box, and here I'll press on OK. As I press on OK, it will take me to the output window, and here in the output window I'll find three tables. So the first table, it simply tells me the number of observations and how many valid cases are there. So this is just a simply a summary table. Second table, it only tells me the observed and expected values, and the third table is actually, it gives us the result on the basis of which we can take the decision in hypothesis testing. So let me first talk on this second table. Here you can see that the male here is gender coded, so the actual count, actual numbers are, there are 36 male and 36 plus 10, total males are 46, but 36 male are smoker, 10 males are non-smoker. So for the female are concerned, there are 16 female who are smoker and 38 female who are non-smoker, but these values are actual values. Now what about this? These values are expected count. These values are expected count, and expected count been computed on the basis of your data. So here in the S.P.S.S, it is been computed automatically using its own techniques by the software. Fine. But in the MS Excel, we need to compute this. How to compute that part also we are going to discuss in the upcoming slides. However, here in the table number 2, there are two things, the actual counts and the expected counts. Fine. Now let me take you all to the third table, and to go to third table, let me scroll it down little. So here is the third table, and in the third table I am going to take my decision on the basis of Pearson chi-square value here, and here is the significance level two-sided, and that is 0.00. So here is the p value, and this value that we are going to use to take the decision here in the hypothesis testing. Here is the p value, and this p value is 0.000. This is less than 0.05, that is alpha level of significance. So that what will be our decision? That we are going to reject null hypothesis, and we are going to accept alternate hypothesis. It means that the smoking and the gender, they are dependent, they are not independent, they are dependent. There is a kind of relationship between these two variables, these two nominal variables. So this is the way that we perform chi-square test of independence in the S.P.S.S. Now let me take you all to the chi-square test of independence using MS Excel. How to perform chi-square test here in the MS Excel? For that, here we'll open our MS Excel sheet. So here is the worksheet, and in this worksheet we are having the data. Now simply I'll go to the insert thing. I'll click on insert because we need to first construct cross table, and to construct cross table we need to go to the pivot table. So how to use pivot tables to construct the cross table, all this part we have covered somewhere in the previous lecture. Still we are going to revise this part in a very fraction of seconds. So let me click here on the pivot table, then I'll select the data, then I'll click on this thing and I have selected my data. Then I'll simply select my data, I'll go to existing worksheet and location, I'll choose my location. So here a new kind of pop-up window appears here on the right hand side, and now simply I'll click on the gender. So gender, it is here in the row label. Then I'll click on the, say that smoking, here is the column label. If you observe carefully, I have taken this serial number also. So three things: gender, it is here in the row label. Row label means in the rows you will find the gender attributes. In the column you will find the smoking attributes. There are two attributes, yes and no type of question, and values, that is sum of serial number. Now if you all remember that I'll have to make some arrangement so that I'll get the frequencies here. So to do that, what I'll do, I'll simply click here on this sum of serial number, then I'll go to value fill setting, I'll click on value fill setting, then instead of sum I'll click on the count, because if you observe here these numbers are just the summation of these different serial numbers. So we don't need sum, we need count. Count means how many counts for the male who smokes and how many counts for the male who don't smoke, and those numbers that we actually need here in this table. We just want our frequencies, fine. So what I'll do, I'll simply click here on the count and I'll press on OK. So here is my cross table. Again, this MS Excel, I need to sort it in a proper way, because my female is here, male is here, or no comes first and yes comes little later. So if I want yes here at the first place and no at the second place, say that if I just want male in the first place and female in the second place, then I'll have to go for the sorting thing. So if I go here to the row label, I'll click on this and I'll just click on the sort Z to A. If I do that, my male, it appears here and the female appears here. Then if I go to column labels, I'll click here, then I'll go for sort Z to A. Again I'll click on this, my yes appears here and no appears here. There is no problem, even if you don't arrange in a such a pattern, still you are going to get the same result. There is no issue. Means you can put this female on the first position, male on the second position, no problem. You can put the no option here in the first position and yes on the second position, no problem at all. You are going to get the same results, fine. But just for the sake of simplicity and to make you understand that how can we sort these attributes, I just explained that this is the way that we can arrange our data. So once our cross table is ready, how to construct cross table, this part we already have seen in a separate lecture in the previous lecture. Still we have revised this part. Now onward we are going to talk on the chi-square test, how to perform chi-square test. To perform chi-square test, first let me type this data here in this pattern. The same data with the same cross table, here I have typed male female and yes, smoking yes and no or non-smoker, and here are the response. These are the frequencies. These are actual or observed counts. These are observed counts. And now I am going to compute the expected counts. I am going to compute expected count. So here is one formula to compute the expected count. How to compute expected count? Row total. What does that mean? It means, suppose if I just want to compute here expected count for the male smoker, then I need to compute this in a such a way that I need to go to row total. Row total means for this row, for the male, how much is the total? That is 46. So 46 multiplied by column total. Column total means for this expected count, here is the column total, that is 52. So 52 divided by grand total. And how much is the grand total? 100. So 46 multiplied by 52 divided by 100, whatever the value that I'll get, I'll place that value here. And to do that, what simply I'll do, I'll give equal to sign, then I'll press on K3. K3 is, here is the K and this is the 3. So this is actually K3. K3 multiplied by this I5. So this is I5 divided by total number, that is 100, that is K5. So here is the K5. Now if I press enter, I am going to get the expected count. The expected count on the basis of these numbers, these total numbers. Correct? I am going to get the expected count. In the same pattern, I am going to compute expected count for the others too. For example, here in the female case, for the female, row total is 54, column total is 52. So 54 multiplied by 52 divided by this 100. K4 multiplied by I5 divided by K5. So I am going to get the expected count for the female. Same pattern I will compute here for the male non-smoker. Again the row total multiplied by column total divided by grand total. And for the female non-smoker, again the row total multiplied by column total divided by grand total. So I am going to get the female non-smoker count, expected count for the female non-smoker. Now if I add all these numbers, I'll get the sum of all these numbers. Fine. Now to perform chi-square test here in the MS Excel, I'll simply put equal to sign and I'll just start typing the chi-square or the chi-test, CHITEST. That's the formula or that's the function which is available here in the MS Excel. So I'll just double click on this, and once I double click on this chi-test, then I'll have to select the range. And which range I'll have to select? First I'll have to select the actual observed counts. So these 4 counts, not the total, no, only the observed counts I'm going to select. Then I'll have to put the comma and then I'm going to select this expected count. So how I'm going to do that, let me show you. So I have selected these 4 cells, then I'll place comma and then I'll select these 4 cells, only these 4 cells, and then I'll close the bracket and I'll press enter. As I press enter, I'll get the p value. So here is the p value. Now if you observe here the p value, what is the p value? Someone can say, sir, the p value is 1.22 and this is greater than 0.05. So that will take the decision that no, we cannot reject the null. But this is not the case. This is wrong interpretation. Whenever we get kind of value where, if you carefully observe here, the alphabet E is here, then the dash is there, then 0 and 6 kind of things are there. Whenever you find such kind of number in the MS Excel, it represents that the p value is highly significant, like 0, there are many zeros and somewhere there is value, a particular value. And this part also we have discussed somewhere in the previous lecture. Still, suppose if you just want to convert this number here in this actual figure, then how to convert it? For that, simply I need to just right click on this cell. As I click here, right click here on this cell, I'll go to the format cells, and in the format cells I'll simply click on the number. And as I click on the number, a new kind of options they appears here in this pop-up window. Then I'll have to just increase the decimal places 6, And why I'm going to make it 6? Because here in this number, here it is 6. So what will happen? After 6 points there is particular number. So this is the way we are going to define it here. Once I made it 6, then I'll click on OK, and if I click here on the OK, I'm going to get the number, that p value, and this p value, if you observe, 0.00000, and on the 6th position there is 1. So this is less than 0.05, and if your p value is less than your level of significance alpha, then we reject null and we accept alternate hypothesis. So this is the decision criteria that already we know. So this is the way that we perform chi-square here in the MS Excel. Now if I go to the S.P.S.S and MS Excel results, I am going to get the same result, 0.000 here in the S.P.S.S, and here also I am going to get the same result, 0.000. So in both the cases we are going to get the same result, and that is why what would be the decision? Decision is that if my p value is less than the alpha, then we reject null and accept alternate. It means the smoking habit and gender are dependent, or there is a significant relationship between the smoking habit and gender. Again, please don't get confused here. Here the mu, it doesn't mean mean. For just simplicity, for the sake of understanding, we have placed it. That's fine. The smoke is not equal to gender. Fine, because in the non-parametric test, mean doesn't work. Here, median can work. Fine. So this is the way that we perform chi-square in the S.P.S.S and MS Excel, and this is the way that we interpret and read the results. So I hope you all have understood this lecture, and you will use these techniques in your research too. So far this lecture is concerned, we'll stop here. See you soon in the next lecture. Thank you.